So you know from the video that we just watched that if you drop Mentos candy into a bottle of Diet Coke that it will fizz and shoot out the top, right? Like a fountain or in a fountain. Okay? A physics class hypothesized that dropping more Mentos into the bottle would create a higher stream of soda. Before I go on, is that, do you think, an appropriate hypothesis? Right? It's something to start with for sure, right? Now, some people earlier had a problem with me telling you that this was a physics class and not an algebra class. I just want to make sure you guys understand that sometimes in math, we talk about like science stuff. And even in math, sometimes we like write like in English. And like sometimes in science class, you do math. Sometimes in band, we make geometric shapes like geometry, like math. Sometimes in theater, you read like in English, right? Are you guys okay with that? It's called cross-curricular. That's a good thing, okay? All right, the class conducted an experiment with several packages of the candy and 8 2-liter bottles of soda. Here's the results. What do you notice about the results? Just give everybody a second, okay? Just look at the results for a second. Don't say anything. Just look at it. Now tell me, what do you notice about the results? It's not complete. Why is it not complete? We all have those friends, right? We all have these friends who are going to do an experiment, but they accidentally knocked over their Coke bottles. Oh, geez, not again. Right? But that happened here. Okay, so we have to take that into account when we're working on this paper. Okay, so first of all, it asks us to make a scatter plot of the data. Do you remember how to make a scatter plot in your calculator? May I remind you? Okay. I'm going to zoom in. You can't see my keypad, but you can see my screen. Is that okay? All right. So first thing we're going to do is we're going to make a list and spreadsheet. Oh, sorry. First thing we're going to do is turn the calculator on. Okay. Then we're going to go to our home button right here. If you're not already there, make a new document. When we made a new document, we want it to be a list and a spreadsheet. So number 4. Okay, does yours look like this? Awesome. I want to scoot up to the top of this column where it says A. What kind of information is going to go in my X column? What kind of information is going to go in my X column? Number of Mentos. So I actually want to type in number of Mentos. I'm only going to type in Mentos because that's what all I want to do. Okay, but I could type in number of Mentos if I wanted. What values are going to go in my X column? 1, 2, 3, 4, 5, 6, 7, 8. You okay with that? What's going to go in my B value here at the top of my Y column? Height of spray. So can I just put height? If you just choose one word, choose the word that makes the most sense for the problem. Okay, because if I put spray there, it doesn't really make sense, you know what I'm saying? Okay, what goes here? 6, 11, 14, 16, If I leave it blank, I'll have a different value of information in my X column and my Y column, and that will corrupt our data. Is it 0 though? You're saying it was 0 height tall? I can't put X. The calculator doesn't recognize that as a value. I know, it's already the second day back and I'm making you think. It's okay. Guys, what's going to go there? Nothing. We can't put anything there, can we? Because if we make up a value, I mean, I guess we could like guess at what was there, but wouldn't that corrupt our data also? But if I put anything there, I'm putting a value that's not true. But if I don't put something there, I'm going to have corrupted data because I'm not going to have the same length of X's as I do have Y's. So what's left to do? I delete the 5. I got to get rid of the 5. I can't use the x value of 5. Now, it also is not going to like that I have a space there. So it's going to have to go there. 6. So I don't need that 6. So what has to go here? Do I want a 7 there? Okay, so what's going to have to go there? 8. So did I know that going into this table? I did, right? I knew that's how we were going to have to set up the table, right? So why did I tell you to begin with to put in a 5 and a 7? To help you think about it, okay? You remember I told you yesterday that I'm taking a class from Stanford University about brain research? One of the things that I've already learned in this class is that the brain research says that when you make a mistake is when your brain grows. Like when your knowledge or learning, when you make a mistake, that's when that grows. Not when you get answers right, but when you make a mistake. And the interesting part of it, at least to me, is that your brain grows even if you don't realize you made a mistake. I don't know how they measure that, guys. I don't know if you don't know that you made a mistake, right? Obviously, you're going to get to the end, like find an answer and the answer is wrong. But somewhere in there, your brain is already growing, realizing it made a mistake. It just didn't tell your brain. Your brain didn't tell your other brain? Your one half of your brain didn't tell your other half of the brain? I don't know. Okay, I really don't understand that. It's something I'm still working on trying to learn. Okay, but we needed to make a mistake right here, so we would have to think about it so that we could grow our knowledge and give ourselves another option. You okay with that? Okay, so what's going to have to go here? 20, and what's going to go here? 22. Okay, now, so we made a scatter plot. Let me zoom back out a little bit. What characteristics of the data indicate that a square root function might be a good model for the data? Well, how about if we look at it? Can we look at it? That might help. So let's do control doc, which will add a page. And the page that we want to add is a data and statistics page. Now, if I were a betting woman, which I am not, I like to keep my money, okay? I would bet that my graph does not look like yours. And I would bet that your graph doesn't look like your neighbor's. Because what the calculator does right now is just kind of throws all the points up there. We have to help it know where everything goes. So remember, I need to move my cursor around until the bottom where it asks me, do you want to put a label here? Remember that? Oh, look. You want to put a label here? Well, yes. I mean, I know it doesn't say that for real. It just says click to add variable, but it's more fun to say the other one. Okay? Yes, I do, in fact, want to put a variable there. What variable goes on my x-axis? Number of mentos. Did you just see that? Did you see the dots move? I don't know about you, but I think that's cool. Maybe it's just me. Okay? So now I'm going to scoot over to the y-axis and I'm going to click to add a variable. Do you want to add a label here? Yes. What's my label? Height. And there it goes again. Now does yours look like mine? Yes, it should. Right? It should. So let's go back and see if we can answer this question again. What characteristics of the data indicate that a square root function might create a good model for this data? What makes you think that this might be a square root function? It looks like one because of the way it looks. Okay? Now, in math, do we normally say our answer is because of how it looks? No, it's asking what might, right? What characteristics indicate that a square root function might create a good data for the model? So is this okay that it's a guess? Okay, so it looks like one. Okay? God bless you. Let h of x be the function that approximates the height of the spray in feet that result from dropping x Mentos into the Coke bottle. Now, a lot of you just heard Blah, 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 Coke. Or maybe you heard Mentos and Coke. Okay? Let's make sure we understand what it's saying. It's saying we're going to call the function h of x. We're giving it a name, h of x. It's going to approximate the height of the spray, and it's very clear that we're talking about height in feet. If we drop so many random number of Mentos into a Coke bottle. Does that translate well? Is that better? Are you guys, I think, are getting much better at translating math to English and English back to math. Is that true? Good. So, number 1 says the rule for h of x can be written like this, where a is a constant. So the first thing we want to do is to determine a value for a that fits this data and tell how you found it. Okay? Now, if I were you, my first thought would be, from here, I want to immediately do menu, analyze, regression, because that's going to tell me exactly what a is, isn't it? So if I do a regression, go ahead and find the square root regression on the list. Yeah, you can't find it because it's not there, right? We can't find it. So in telling how we found it, we can't say we used a regression because there's not a square root regression built into our calculator. So how else do you think we might find it? Okay, if we plot function, that's a good thing to do. What is it asking us to put in? The equation, right? Do we know what a is? Now that's what we're trying to figure out, right? So we're going to use the time-honored tradition in mathematics of guessing. But here's what I want you to do. Honestly, seriously, what I want you to do for the next couple minutes is I want you to work alone. How many times do I ask you to work alone? Very rarely. Usually only on tests, right? Usually I let you work together for a second. But for just a second, I want you to work alone, and I want you to try to figure out what a is. Okay? I want you to try to figure out what a is. Work for just a minute. See if you can get close. Don't say anything. Keep it to yourself for a second. Has anybody gotten something they think might work? If you do, raise your hand. Don't say it out loud. Okay, then keep working. Okay, you be quiet for just a second. Once you get something you think might work, raise your hand so I can know that you're ready. Good, thank you. Thank you. You can put your hands down. Thank you. It's okay. It's okay. You got something? Okay, thank you. let's talk about this for just a second. Where'd you start? Menu, analyze, plot function. So did you start with 1? I think is what I heard. Oh, I can't even see that. Okay, that's not going to work. Where'd you go then? 10. Whoa. That's closer though, isn't it? Okay, so should the number I try be more or less than 10? Why? I need to go lower, right? Okay. So where'd you go? 5. Okay. So too low. So if 10 was too high and 5 was too low, maybe what should I try? 7. Well, that's closer, isn't it? So 10 was too high, 7 is too low. 8. Well, that's pretty close. Do you try anything else? Okay, let's try 9. Okay, so 9's too high. Oh, wait. You realize that there's numbers that are decimals that we could try? Yes. What'd you try? What decimal did you try? 7.5. Okay, is 7.5 better or is 8 better? So we think 8's okay, right? But if we want to try to get closer, how many decimal places could we go to? Like go a whole bunch, right? We don't want to get too OCD on ourselves though, right? So what about 9? Which one's better? 7.9 or 8? 7.9? Do we even remember what 8 looks like? No, I don't either. It's okay. Well, then is 8.1 better? .1 is almost not touching this one anymore, and it's a little too high on that one, right? So maybe 8? Or wait, maybe 7.97? At this point, it doesn't matter, does it? We're pretty darn close. And at this point, we're still guessing, aren't we? Okay, so what do you think that we want to choose? I know that you could choose something as an individual, and I'm not going to change your mind. I'm not going to try to change your mind if you want to choose what you actually got. But maybe as a class, what do you think we might want to choose together? 8? Okay, I'm okay with that. So let me change this to 8 so we can have that on the screen. 8. Are you good with that? So let's go ahead and write that down because it asks us to determine the value for A. So I got A was 8. So my equation is h of x equals 8 times the square root of x. How did we find it? We guessed. Is that a sentence? Did it have a subject and a verb? Yeah? Did I capitalize the first letter and put punctuation at the end? Did I spell everything right? That's all important, right, when we answer our answers. Oh, that's like cross-curricular like we talked about a second ago, right? Excellent. Let's look at the second page, or the second part. Number 2, with your value for A, use your function to estimate the height of the spray for x equals 5 and x equals 7 Mentos. Well, if x equals 5, I would say h of x, or h of 5, in fact, is what I would say, is 8 times the square root of 5. Isn't that what I would say? Okay, I'm going to go ahead and add a page that is a calculator, because I don't know the square root of 5 off the top of my head. Do you? Okay, so it's not just me. What is 8 times the square root of 5? 17.89? Okay, so 17, we can go with 17.89. That's fine with me. 17.89 what? Feet. Because we're estimating the height, right? Whoa. Feet. That's a weird, I'm sorry, my writing is messy. What about when x is 7? H is 7. is 8 times the square root of 7. And you said it's what? 21.1 feet? Okay, before I go on, I need to make sure those answers make sense. How would I make sure those answers make sense? I did plug it in and I got an answer. Those are all good ways that we normally check, but how could I specifically check for this particular problem? Do I know what the answer was when h was 5? When the height was 5? I don't, do I? That's the one that got knocked over. But does 17.89 feet make sense in between these two numbers? It does, doesn't it? What about 21.1 for 7? That does make sense, right? So even if I'm a little bit off because I rounded a little bit, those answers still make sense, don't they? Okay, so those are reasonable answers. All right, with your function rule, estimate how high the soda would shoot out of the bottle if you used 10 Mentos. What am I doing different than I did on number 2? Am I doing anything different than I did on number 2? No, I'm just using x equals 10, right? So I'm finding h of 10 equals 8 times the square root of 10. So 8 times the square root of 10. What did you get? 25.30? Or 30? Yeah, it's the same thing. Feet? Guys, is there any way I can check that? Back here, I could go look at the table. Do we know 9 or 11? We don't. They only went to 8. So what we're doing here is we're kind of like we're estimating, but we're predicting what would happen if there was 10, aren't we? Okay. Using your function rule, set up and solve an inequality to determine the number of Mentos you would have to use for the spray to go at least 30 feet in the air. What do you think I should start with? I should start with my function rule, shouldn't I? So 8 root of x should have something to do with 30. If I know this needs to be an inequality, what does 8 root x have to do with 30? That's exactly right. Greater than or equal to 30. At least 30 means 30 is the lowest it can be. We want it to probably be higher than that, right? So that would be greater than or equal. Now, how do I go about solving this inequality? Yeah, get rid of the 8. I know what you meant. It's okay. So square root of x is greater than or equal to 30 divided by 8? .75. And now? Square both sides. Very good. X is greater than or equal to? We're just going to go all the way here. 14 point... What'd you say? Yep. 0.625. So I have solved the inequality, haven't I? So let's make sure we're answering the question correctly. Use a function rule, set up and solve an inequality to determine the number of Mentos you would have to use for the spray to go at least 30 feet in the air. How many Mentos would we have to use for the spray to go at least 30 feet in the air? 14? Okay, so let's talk about this real quick. 8 times the square root of 14 is not 30. I totally agree with you that if I was rounding this number, I would round it to 14. But if I need this to be at least 30, is 14 going to do that for me? No. Guys, why wouldn't you say 14.0625 Mentos? That would be ridiculous, wouldn't it? What would be the most logical answer for this problem? 15 Mentos. Now, they argued with me a little bit that we could do 14 and a half. Guys, I totally agree with that. We could do 14 and a half, right? We could even do 14 and a fourth. We could probably cut a Mentos in a fourth. But I don't really like the idea of some of you with a knife. Just being honest. So let's just go with 15. Are you okay with that? Okay. Using your function rule, set up and solve an equation to determine the number of Mentos required for the spray to reach a height of 50 feet. So this time we're not doing any equality, we're doing an equation, right? So 8 root x equals 50. Do I solve it any different? Nah. Divide both sides by 8. Square root of x equals 50 divided by 8 is 6.2.